Hello, parents. This is Chris Allen from Paramarian High School, and I wanted to give you an update on the week of April 5. So, in geometry, we were looking at segments of a circle and particular chords, and students might be asked to find the value of x in a problem similar to this one. And so, the first thing that a student would hopefully realize is just by looking at the picture that we can see the center of the circle and we can see that there's a perpendicular set of segments there. And since those segments are perpendicular to that diameter, which is what that is, we can conclude that the segment on the right here is congruent to the segment on the left. Therefore, that means the segment on the left has to be 8.3. We've got a right triangle there on the left, so that means that we can do the Pythagorean theorem. So 8.3 squared plus 4.4 squared has to equal x squared. And with a little bit of calculation, we can get that x is approximately 9.394. In calculus AB, we are looking at the area between two curves. So I've given the equation of two curves here. One of them is the ln of x. The second one is sine 3x plus 1 plus 4. And we're going to bound those two graphs between 3 and 9. So in other words, we're going to go from x equals 3 to x equals 9. So we're talking about this area below the sine curve there in blue and above the natural log curve on the bottom in red. So to calculate that area, we're simply going to integrate from 3 to 9, y sub 2, which is our sine curve, minus y sub 1. We want to do the top minus the bottom. And the answer turns out to be 13.562 approximately. In calculus BC, we'll be looking at parametric equations. So I've got the parametric equations for this prolate cycloid. The graph is this black curve on the right. Students are asked to find the tangent lines at the point 0, 2. So first thing we would do is we need to establish what the value of t is going to be for this that we're going to have to find. In this case, since we know that x is equal to 0, well, we'll just let x become 0 and try to figure out which t values. And by the way, there's multiple t values that will produce that 0. And it turns out that the ones that we're going to use is going to be pi over 2 and negative pi over 2. And you would also do the second parametric equation y to figure out when that guy is 2. Anyways, we're going to find the derivative now because we're trying to find the equations of the tangent lines. And the derivative for a system or a parametrically written equation is you do the derivative of the y coordinate on the top divided by the derivative of the x coordinate. In other words, we're going to do the derivative of 2 minus pi cosine t on the numerator. That's this. And then divide that by the derivative of the x coordinate. We need to figure out what that is for t equaling plus or minus pi over 2, which turns out to be pi over 2 plus or minus. And therefore, our final answer here, let me get that out of the way, sorry about that, is going to be y equals plus or minus pi over 2x plus 2. Okay, another quick reminder for the ABC parents. Before spring break, I gave the students a mock exam on Canvas. This week, talking to my AB students, it appears that several students have not quite done that yet. So I'm going to remind them that they definitely want to get that done ASAP. It is not for a grade, but they definitely want to do that before they actually take the AP exam. By the way, the AP exam is going to be for calculus, Tuesday, May 4th at 8 a.m. Final thoughts. Number one, classes are fuller. That's great. More students are back in person. It's really nice to have students in the classroom. So I am excited about that. If your son or daughter is still virtual, obviously that's fine. But we're progressing, I hope. And please, again, continue, students, to have a focused effort in class. I know it's after spring break. It's getting towards the end of the year. But now is not the time to let off the gas. Keep your foot on the pedal. Let's go all the way through, okay? Get to the end of the year before you take a break. And finally, I'd like to remind parents and students that we have advisory periods on Thursday, the last period of the day on Thursday and Friday. I'm available for extra help if a student feels like they need some extra help, that whether they're here in person or virtually, we can set up a time during that period for them to come and chat with me. And I would love to do that. So thank you so much for your time.